I'm Rayesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
Imagine a future where our phones roll up like paper, our clothes generate electricity, and our homes are powered by solar cells printed as easily as newspapers. That future is closer than you think, and it's being built with organic electronics. For decades, traditional electronics have relied on rigid, silicon-based materials. They've powered our computers, smartphones, and just about every modern device. But silicon has its limits. It's costly, it's rigid, and it demands enormous factories and energy-intensive processes to manufacture. Organic electronics are rewriting those rules. These are carbon-based materials, essentially specialized plastics that can conduct electricity, emit light, or even store energy. Unlike silicon, they're flexible, lightweight, and can be processed into inks. That means circuits and components can be printed directly onto plastic films, clothing, or even curved surfaces. Imagine electronics as adaptable as the surfaces they're placed on. The breakthroughs are already here. Organic light-emitting diodes, or OLEDs, are lighting up millions of smartphones and TVs with vibrant, energy-efficient displays. Organic solar cells promise thin, bendable panels that could be woven into fabrics, applied to windows, or wrapped around vehicles. And organic batteries built from non-toxic, biodegradable materials are being designed to replace heavy, resource-intensive lithium-ion technology. One of the most exciting areas is in radical polymers, transparent, conductive plastics that look like ordinary plexiglass, but carry electricity. These materials could enable low-cost solar cells, lightweight batteries, and ultra-thin coatings that prevent static buildup in consumer electronics and even aircraft. Organic field effect transistors are another game-changer. These are the building blocks of circuits, but now, instead of rigid silicon chips, we could have ultra-thin, flexible circuits integrated into bendable displays, wearable sensors, and even smart textiles. Imagine a shirt that monitors your heart rate or shoes that track your performance, all powered by organic electronics seamlessly embedded in the fabric. Recent discoveries are pushing performance even further. Researchers in Sweden have demonstrated double-doping polymers, effectively doubling their conductivity compared to earlier designs. Others are working on transparent, conductive coatings that balance clarity with electrical performance, perfect for touch screens, solar windows, and lighting panels. And while challenges remain, like improving stability, scaling up manufacturing, and increasing efficiency, the trajectory is clear. Organic electronics are not just an alternative to silicon, they are an evolution toward greener, more versatile, and more sustainable technology. Think about the possibilities. Wearable devices that bend and stretch with us, solar panels that roll up for easy transport, biodegradable batteries that reduce e-waste, and medical sensors that conform naturally to the human body. Organic electronics unlock a future where technology isn't confined to rigid boxes but is woven into the fabric of our daily lives, literally. The age of silicon may have defined the last 50 years, but the next era of electronics may very well be organic, flexible, and sustainable. The revolution has already begun, and it's one that could transform not just how we use technology, but how we live with it.